In this section, we will be graphing more complicated quadratic equations. So these ones are all going to have a term in the middle that has an x in it. And in this box here, I have the general formula of a quadratic equation, which is y equals ax squared plus bx plus c. This is called standard form. So you're always going to want to write everything in this form where you have y equals something. So then when you look at it, you can automatically tell a few things about your graph based on the equation. So first, you're going to look at the coefficient of the x squared. So if that is greater than 0, if that's positive, then the graph is going to open up. And what I mean by that is that your parabola is going to look like a U. If your coefficient of your x squared is negative, if it's less than 0, it's going to open down. In that case, it'll look more like an N. It's kind of an upside down U. And the other thing that's really important is that your y-intercept is going to be at whatever your constant value is, your c. So it's going to be at x equals 0. That's where our y-intercept always is, at x equals 0. And then whatever the c value is. So then the vertex and the axis of symmetry are going to be a little bit harder to find because there's a formula, and you do have to memorize this formula. So the vertex is going to have an x-coordinate of negative b over 2a. We don't have a formula for the y-coordinate, but I'll show you how to find it in just a minute. The axis of symmetry actually has the same value for x, but it's going to be a straight vertical line. And remember, a straight vertical line has an equation of x equals something. So the axis of symmetry is going to be x equals, and it's also going to be negative b over 2a. We're going to go through a few examples now. And for all these examples, I'm going to ask you to find the vertex and the axis of symmetry, and then to graph. So for this one, I have y equals 5x squared plus 10x minus 3. If you notice, this is already solved for y, which is really important. So what I'm going to do is I'm going to use the general formula that I had in the previous slide to help me figure out what my a, b, and c are. Those are going to tell me all sorts of good things about this graph. So my a is going to be the number with the x squared, which is 5. My b is the coefficient of the x, which is 10. And my c is my constant, which is negative 1. So once I have those, I can do a lot of things, starting with my vertex. And on the previous page, you might know that the vertex has an x-coordinate of negative b over 2a. And in this case, my b is 10, my a is 5, so when I calculate it out, I get negative 10 over 10, which gives me an x-coordinate of 1. So now to find the y-coordinate, you have to substitute x equals negative 1 into your equation. And when I do that, I get y equals 5 times negative 1 squared plus 10 times negative 1 minus 3. So just make sure that you follow your order of operations here. That's really the main place that people make mistakes. We're going to start with our exponent, which is the negative 1 to the second. That gives me 5 times 1. 10 times negative 1 gives me minus 10, and then I have minus 3. In the end, I get negative 8 when I solve that all out, so my vertex is at negative 1, negative 8. For part B, I asked you to find the axis of symmetry. One little hint for that is that it is always the exact same thing as the x-coordinate of the vertex. So You don't really have to do any work once you've found the vertex. It's just going to be at x equals -1. So now from there, I have a few things that'll help me out with my graph. And so the first thing I know is that my vertex is at -1, -8. The second thing I know is that it's going to open up. And the reason for that is because A is positive. And that's going to help me a lot. The last thing I know is from my C, I can find my y-intercept. So I know my y-intercept is going to be at 0, -3. And once I have all those, I can graph. So I'm going to start with my vertex at -1, -8. If you want on your graph, you can feel free to go by 2s rather than going by 1s. I know that not everybody has enough space on their graph. Actually, that one was at 7, so I'm going to fix it. So I'm going to start with my vertex. The next thing I have is my y-intercept, which is all the way at 0, -3. Remember, this is my y-axis, the vertical one is. From there, if you want, you can draw your axis of symmetry. You don't have to, though, but it's going to tell us something important. So I'm going to just draw it in yellow. It's very hard to see, but that's okay because it's not really a part of the graph. So the axis of symmetry is going to tell us that the points that we have on either side of that line are going to be reflected. So this point I have on 0, -3 is actually going to be reflected over that line, so I have another point on the exact opposite side of that axis of symmetry. From there, I can just draw my graph through there. It's helpful that I know that it opens up, and it's going to look like that. Hopefully yours looks a little better than mine. I drew it with my finger on an iPad, so it doesn't look that good, but it should be curved and kind of U-shaped. So just do the best that you can to draw it. So here's our next example. If you're feeling really comfortable with this, go ahead and find the vertex and axis of symmetry on your own, and you can even graph if you want. If not, then you can just follow along as I do it. So for this one, we know that our general form is y equals ax squared plus bx plus c. In this case, you probably immediately can tell what the b is and what the c is. So the b is 4, the c is 8. Just remember that with when you have something like x squared with no coefficient in front of it, it doesn't mean that it doesn't exist or that it's 0. It just means that there's a 1 in front of there. So you can even write the 1 in if you want. So a is going to be 1. That's going to be really important and helpful for the next part. And we are now going to find our vertex. Remember, the x-coordinate is -b over 2a. Which is going to be -4 over 2 times 1. When I work that out, I get a vertex of -2 for my x-coordinate. To find the y, I need to calculate out, using this equation, the y equals x squared plus 4x plus 8. I'm going to substitute in -2 for x. And then when I do that, I get 4 minus 8 plus 8. That gives me a y-coordinate of 4. So this is my vertex. So that's the first important thing. The second important thing, that was part A by the way, part B is the axis of symmetry. Don't try to make this one too hard. You could just take the x-coordinate that you calculated out in the beginning and use it from there. So our axis of symmetry here is going to be x equals -2. Now part C is the most involved part just because there's a lot of things to do. So we know a few things. We know the vertex. We know that it's going to open up because our a, which is the coefficient of our x squared, is positive. We also know that we have a y-intercept at 0, positive 8. We get that based on our c value. So from there, we can do a lot of things with this graph now. So we are going to start with our vertex at negative 2, 4. And we know that we have an intercept up at 0, 8, so I'm going to draw that in too. If you want to draw in your axis of symmetry, feel free to. You don't have to. It's not an essential part of the graph, but it's going to help you to reflect that intercept over to the other side. So you'll notice that my y-intercept is 2 spaces away from my axis of symmetry. I'm going to do the same thing on the opposite side. And from there, I'm going to graph it, and sure enough, it's going to open up, which is what I wanted it to do. And that's my answer for that one. So one other thing that's really important is that if you get stuck, or if you say, I really, really need help drawing this graph and I really want it to be perfect, one thing that you can actually do is draw an XY table. So if you were to do an XY table for this, my recommendation would be start at the vertex. We know that the point negative 2, 4 is on the line. That is our vertex. If you do 1 point on either side of it, that will help you out. You can even do 2 points on either side of it. So when you do that, you will just take that x value, substitute it into your original equation. So I'm going to do it with negative 1 into my original equation. When I do that, I get y equals 1 minus 4 plus 8, which gives me y equals 5. You'll notice that in my picture, I didn't exactly hit 5 at that point. I tried the best I could, but it's not perfect. If you have the general idea of the curve and you have the vertex right and you know it opens up, that's the main thing I want you to get right now. But if you could try to make it as good as possible, that's good. The other thing that's helpful is that because of our axis of symmetry, we know that the points are going to reflect around it. So we know our vertex is negative 2, 4. X equals negative 1 is 1 space away, and it has a y of 5. X equals negative 3 is also 1 space away, and it's also going to have a y of 5. So you can use that property to help you out with filling in this table.